Okay, so we're creating tables for exercise number 3 to compare the functions f of n equals 2 times n and f of n equals 2 raised to the power of n. So we're going to start with the function f of n equals 2 times n. So everywhere that I see an n, I replace it with the value in the n column. So 2 multiplied by -2 gives me -4. 2 multiplied by -1 gives us -2. 2 multiplied by 0, anything times 0 always gives you 0. Now, 2 times +1 is 2. 2 times +2 is 4. And 2 times +3 is 6. Now, the next step is to take these points and actually graph them on the coordinate plane. So if I start from the top, -2, -4, when x is -2, y is -4, and that's the first point on our graph. Next, -1, -2, when x is -1, y is -2. Next, when x is 0, y is also 0. That is also called the origin. When x is 1, y is 2, so the point 1 up 2. When x is 2, y is 4, so 2, 4. And lastly, when x is 3, over 3 up 6. And this function is continuous, so therefore we can go through and connect the dots. And finally, I did go ahead and connect the dots with a line, and I labeled our function f of n equals 2 times n. So the next function is f of n equals 2 raised to the power of n. So we're going to go through and graph that. So in this case, everywhere we see an n, we still replace it for the number in this column, but now it's an exponent. So the very first one, 2 raised to the -2 power. When you raise something to the negative, it actually means it's lost, so it needs to go into the denominator. And this is really 1 over 4. So the same idea works with 2 to the -1, meaning the 2 becomes the denominator, and our result is 1 over 2. Now, anything raised to the 0 power, 2 raised to the power of 0, is actually 1. Anything to the first power is itself, so 2 to the first power is 2. In the next step, we multiply 2 times 2. 2 to the second power, we get 4. And lastly, 2 to the third power is not 6. It's 2 times 2, which is 4, times 2 one more time. 4 times 2 is 8. And that's how we get the values for the second table. And now we're going to plot these points on our graph. Now notice, -2 is 1/4. So if I go to -2 on my x-axis, I just go up 1/4. It's not to the halfway point. It's actually halfway to the halfway point. So then -1 is actually going to be the halfway point. And then when we get to 0, when x is 0, we're actually at 1. When x is 1, we go to 2. And notice, that's a point on our line already. When x is 2, we go to 4. That's another point on our line. And then finally, when x is 3, we go up to 8. And now we're going to connect these dots with what's known as an exponential curve and label this function. So that is the function f of n equals 2 raised to the power of n. And one thing that I want you to pay close attention to is this area right here. From this point, the line crosses over the exponential curve and then back again, right? So in here, at here and here, those two values are the same. Beyond that point, our exponential function is headed almost straight up, not quite, but going very much in the upward direction where the line has that slope. So from this point on, that exponential is going to increase a lot faster than the linear. And that's why those exponential numbers get really, really big over time. And that is our graph for question exercise